You think war machines are just engineering. Catapults, siege towers, battering rams, tools built by craftsmen who know wood and rope and iron. But in 213 BC on the coast of Sicily, one man turned mathematics into a weapon that held off the most powerful army on Earth for 3 years. Not because he loved war, because he understood leverage, displacement, and trajectories better than any human alive. His name was Archimedes. The process he used to design those machines will change how you see strategy forever. Spent his youth in Alexandria studying under the successors of Euclid. Mathematics was his obsession, pure geometry, calculating the value of pi to remarkable precision, proving that a sphere inscribed in a cylinder has 2/3 the volume of that cylinder. Work that would echo through 23 centuries. But Archimedes hated practical applications. Plutarch wrote that he viewed engineering as beneath him, crude work, a distraction from truth. The siege began in 213 BC at the quarter called Hexapylae on land, and at the portico of Sidus in Acradina by sea. 18,000 Romans, wicker screens, siege towers, scaling ladders mounted on ships, the Sambuca, a floating platform with grappling hooks. Marcellus believed he would take the city in 5 days. Polybius recorded that exact estimate, 5 days. He did not account for one old mathematician who had spent years building a stockpile of machines for Hero, machines that sat unused because Hero spent his reign in peace, but the apparatus was ready, and so was the engineer. This script is researched and factual, using sources from Polybius's Histories Book 8, written around 150 BC, based on first-hand Roman accounts, Plutarch's Life of Marcellus from around 100 AD, and Livy's Ab Urbe Condita from the late 1st century BC. We also reference modern archaeological analysis published in the Journal of Roman Archaeology, Volume 33 from 2020, and the Cambridge Companion to Archimedes from 2023. These are not popular history summaries. These are primary sources cross-referenced with physical evidence from Syracuse excavations. Now back to the information. He designed them the way a mathematician solves a proof. Start with principles. The law of the lever, he had proven it in his treatise. On the equilibrium of planes. Magnitudes are in equilibrium at distances reciprocally proportional to their weights. Simple. A small force at a long distance can move a massive weight at a short distance. That was not philosophy, that was physics he could quantify. Weight times distance from fulcrum equals weight times distance on the other side. Mechanical advantage is the ratio of those distances. He had demonstrated this for Hiero years earlier with a pulley system that moved a fully loaded ship across dry ground. One man, one lever. Plutarch recorded that Archimedes told Hero he could move the earth itself if given a place to stand and a lever long enough. Hero was astonished. He asked Archimedes to build engines for offense and defense. Archimedes complied, not because he wanted to, because it was his duty. Stone throwers that could hurl 500-pound boulders. Polybius specifically states that operators could change the range. That means Archimedes built adjustable tension mechanisms, variable trajectory. He was not guessing. He was computing parabolic arcs. Distance equals initial velocity squared times sine of twice the angle divided by gravity. He did not have that formula in modern notation, but he understood the geometry. The angle of release determines the path. The force determines the distance. Adjust one, adjust the other, hit the target. Long range, mid-range, point blank, constant barrage, no safe approach. That is not instinct, that is systematic thinking. Identify the problem. The problem is enemy approach from multiple distances. Solution. Zone defense using mathematics, calculate effective ranges, deploy weapons accordingly. All three describe massive beams extending from the walls, cranes, grappling hooks. The mechanism is precise. A crane arm pivots on the wall. A rope and pulley system raises and lowers the hook. The hook grabs the prow of a ship. The operator lifts the prow until the ship stands vertical on its stern. Then he locks the crane mechanism so it cannot move. Finally, he releases the grappling hook suddenly using a rope and pulley. The ship either capsizes sideways or plunges bow first into the water and fills. Some vessels heeled over and fell on their sides, others completely capsized. The majority, when their bows were dropped from a height, went underwater and filled. Those are Polybius's exact words from Book 8. Marcellus's operations were completely frustrated. The garrison not only repulsed attacks with heavy losses, but laughed at Roman efforts. Think about what that requires. Archimedes had to calculate the weight of a Roman quinquereme, estimate crew and cargo, determine the center of gravity. A quinquereme with siege ladders raised is top-heavy, unstable. Lift the prow, shift the center of gravity past the tipping point the ship cannot recover. That is applied geometry. He also had to calculate crane arm length, pulley ratios for mechanical advantage, material strength of the beam. Tension in the rope. Load capacity. This is not trial and error. Experimental archaeologists in 1999 built a scale model. They used ancient materials, wood, rope, iron hook. They successfully lifted and capsized a model galley. The math works. The mechanics work. Archimedes built it because he understood the physics. Fired through loopholes a palm's breadth wide at the outer surface of the walls. Polybius describes this. When Roman ships approached under cover of darkness, thinking they were too close for the large catapults, Archimedes had the walls pierced with loopholes at the height of a man. Defenders inside could fire arrows and darts through these slits continuously. The Romans could not see the shooters, could not reach them. The volleys were extraordinarily rapid and sharp. Hero had provided supplies. Archimedes had designed the rate of fire, probably calculated reload time, optimized the number of shooters per loophole, coordinated fire zones, again, systematic, not random. While attacking ships were still at a distance, he scored many hits with catapults and stone throwers, causing severe damage. As the distance decreased and these weapons began to carry over enemy heads, he resorted to smaller and smaller machines. This demoralized the Romans. Their advance was brought to a standstill. Marcellus, in despair, tried bringing ships up secretly under cover of darkness. But when they almost reached shore too close for catapults, Archimedes had another weapon ready, the loophole system. He anticipated every range, every approach. That is predictive modeling. Think like the enemy. Map their options. Close every option with a calculated response. Plutarch recorded that when Romans attacked under cover of penthouses, they were killed by stones and beams let down upon their heads. Gravity-driven weapons. Simple physics. Potential energy equals mass times, gravity times height. A stone dropped from 30 feet delivers enormous force. Archimedes knew the height of the walls, knew the weight of available stones, could calculate impact force, could predict the effect on Roman siege equipment and soldiers. Modern engineering analysis published in 2020 estimated that a 200-pound stone dropped from 40 feet would deliver approximately 8,000 pounds of force on impact. Enough to shatter wood, crush armor, destroy a penthouse. A ship-mounted siege tower with grappling hooks and scaling ladders lowered onto walls with pulleys. Named after a musical instrument it resembled, first deployed in 213 BC specifically for this siege. Attributed to Heraclides of Tarentum, the Romans were confident. Polybius states they felt that with so many hands employed, they would in 5 days advance their works enough to give them advantage over the enemy. But they failed to reckon with the talents of Archimedes, failed to foresee that in some cases the genius of one man is far more effective than superiority in numbers. That line is directly from Polybius, one man, one intellect, properly qualified for the particular undertaking, a host in itself. Carthaginians tried to relieve Syracuse but were driven back. They attempted a second relief but could not afford the necessary troops and ships with the ongoing war in Hispania. Syracuse was on its own, but the Carthaginians successfully resupplied the city. Roman frustration grew. 8 months passed. No stratagem or measure of daring was left untried. Appius Claudius Pulcher commanded land forces. He attacked at Hexapoli, pulled back. Summoned a council of war with military tribunes. Unanimously decided to try any means except storm. Marcellus joked bitterly. He told his officers that Archimedes uses my ships to ladle seawater into his wine cups, but my Sambuca band has been whipped out of the wine party as intruders. Polybius preserved that quote. Even in defeat, Marcellus acknowledged the brilliance opposing him. Romans concluded that the best way to reduce Syracuse was by starvation, cut supplies from the sea with the fleet, cut supplies from land with the army. Wait. The city had a large population. Eventually, hunger would force surrender, so they waited. Polybius states this explicitly. They did not dare attempt an attack by any method which made it possible for Archimedes to oppose them. They feared him, one 78-year-old mathematician. The source of their terror was not the machines themselves. It was the mind behind them. They knew that if they tried to breach the walls, he would have a solution. Another weapon, another calculation. They knew he was systematically closing every option. Calculate the physics of each approach, range, trajectory, force required to stop it. Step 3. Design a weapon optimized for each scenario. Large catapults for distance, medium for mid-range, scorpions for close range, cranes for ships, beams for siege equipment. Step 4. Integrate defenses so no gap exists. Layered zones, overlapping fields of fire, no safe approach at any range. That is strategic thinking. He was not reacting. He was predicting, mapping every possibility, countering each one mathematically. Let physics do the work. Gravity capsizes the ship. The crane is just the delivery mechanism. The real weapon is understanding equilibrium, understanding that a ship with its prow lifted high and its stern in the water is inherently unstable. Release it suddenly, it cannot recover. That is not engineering. That is applied mathematics. He proved the principle of centers of gravity and on the equilibrium of planes. Then he weaponized it. Or consider the loophole system. Roman ships approach at night. They think darkness protects them. They think they are too close for catapults. Archimedes predicted this. He anticipated that the Romans would try to use darkness and proximity to negate his artillery. So he designed a weapon effective at point-blank range that does not require line of sight from the operators. Small slits. Defenders inside fire outward. Romans outside cannot see them, cannot target them, cannot reach them. The slits are a palm's breadth wide at the outer surface. Polybius measured it. Narrow enough to protect defenders, wide enough for continuous volleys. Archimedes calculated the optimal width, maximum defensive coverage, minimum vulnerability, pure geometry. Polybius specifically mentions that operators could change the range. That is not a feature ancient weapons typically had. Fixed catapults launched at one range. If the enemy moved, you rebuilt the machine. Archimedes designed adjustable tension, probably a mechanism to increase or decrease the torsion in the springs. More tension, more energy, longer range. Less tension, shorter range. Same machine, multiple ranges. That is efficiency through mathematics. He calculated the relationship between spring, tension, and projectile distance, probably tested different tensions, recorded results, built a reference table. Operators could dial in the exact range needed. That is systematic experimentation leading to optimized design. A paper published in the Cambridge Companion to Archimedes in 2023 analyzed the physics of the claw. They estimated that a crane arm 20 feet long with a 4-to-1 pulley ratio could lift the prow of a quinquereme, weighing approximately 15 tons, including crew and cargo about 10 feet in the air. That is enough to shift the center of gravity past the tipping point. When released, the ship would capsize in seconds. The math checks. The mechanics check. Archimedes had all the knowledge necessary to make these calculations in 213 BC. He had proven the law of the lever. He understood centers of gravity. He knew how pulleys provide mechanical advantage. He just applied that knowledge to warfare. He viewed them as crude, a waste of his intellect. He wanted to pursue pure mathematics, geometry, proof, truth. Building war machines for Hero was a duty, an obligation, not his passion. Yet when he built them with the same rigor he brought to mathematics. He did not do sloppy work just because it was applied. He brought the same systematic thinking, the same demand for precision, the same insistence on proof. Every weapon he designed was a theorem proved in iron and wood and rope. The claw works because the geometry of equilibrium is true. The catapults hit targets because parabolic trajectories are predictable. The layered defense holds because zone coverage mathematically eliminates gaps. Trajectories follow curves. Centers of mass determine stability. You cannot argue with these facts. You can only use them, so Archimedes used them. He did not try to intimidate the Romans with spectacle. He did not build ornate machines to impress. He built functional systems optimized by mathematics. That is why they worked. That is why the siege lasted 3 years instead of 5 days. In 212 BC, Syracuse held a festival to the goddess Artemis. The defenders became overconfident. They had repelled every Roman assault. They believed themselves invincible. During the festival, security lapsed. Polybius recorded that the Romans received information that the city's inhabitants were participating in celebrations. A small party of Roman soldiers approached under cover of night. They scaled the walls at an undefended section, got into the outer city. Reinforcements poured in. By morning, the outer city had fallen. The main fortress held. Marcellus tightened the siege. 8 more months. The inner citadel was cut off from supplies. Hunger set in. Negotiations began. An Iberian captain named Moriscus, one of 3 prefects of Acradina, decided to save himself. He opened a gate near the fountain of Arethusa. Romans flooded in. The city fell in 212 BC after a total siege of approximately 20 months. A Roman soldier entered, ordered Archimedes to come with him. Archimedes was absorbed in his calculations. He either ignored the soldier or told him to wait, not because he was brave, not because he was defiant, because the problem consumed him. The mathematics mattered more than the chaos outside. The soldier did not know who Archimedes was, did not know about Marcellus's orders. He saw disobedience. He drew his sword. He killed Archimedes on the spot. Even facing death, Archimedes cared more about the geometry than the sword. That is who he was, a man for whom mathematics was more real than life. Sought out Archimedes' relatives, paid them honor, ensured Archimedes received full funeral rites. Plutarch recorded this. Even the conqueror mourned the conquered because he recognized the magnitude of what was lost. They had forgotten it. Cicero found it overgrown with thorns and brambles. On the tomb was carved the figure Archimedes requested, a sphere inscribed in a cylinder. representing his proof that the sphere has 2/3 the volume of the cylinder. That was his greatest achievement in his own eyes. Not the war machines, not the claw, not the defense of Syracuse. The pure mathematics, the proof. Cicero cleaned the tomb, restored it. Later, he wrote that this act was perhaps the most memorable contribution of any Roman to the history of mathematics, recognizing genius even in defeat. Archimedes had walls, some metal, some wood, some rope, and mathematical principles. He held them off for 3 years, not through luck. Through systematic application of physics, he identified every threat, calculated the optimal counter for each threat, built machines to execute those calculations, integrated them into a seamless defense. That is strategic thinking. That is how one mind defeats superior numbers. And it is not just ancient history. The mental process Archimedes used translates directly to modern strategy, military, business, technology, any competitive domain. Step 1. Understand the fundamental principles governing your domain. For Archimedes, that was physics. For you, it might be market dynamics, human psychology, information flow. Whatever the laws are, learn them, not surface level, deep, proof level understanding. Step 2. Map all possible moves your opponent can make, all approaches, all vectors. Archimedes mapped sea approaches, land approaches, multiple ranges. You map market entry points, competitive strategies, customer acquisition channels, exhaustive analysis. Step 3. For each possible move, calculate the optimal counter. Not guess, calculate. Use the principles from step 1 to derive the best response. If the enemy approaches from this distance, use this weapon. If the competitor enters from this angle, deploy this strategy. Step 4. Build systems that execute your counters automatically. Archimedes built layered defenses. You build processes, training, automation, whatever ensures the counter happens reliably. Step 5. Integrate everything so no gaps exist. Overlapping coverage, redundancy, no single point of failure. That is Archimedes' process. That is what held Syracuse for 3 years. That is what made one 78-year-old mathematician more dangerous than 18,000 Roman soldiers. Not magic, not genius in the mystical sense. Systematic thinking, rigorous application of principles, refusal to guess when you can calculate. That is replicable. That is learnable. Comment from which city you are hearing this from. This script uses primary sources. Polybius, Book 8, written around 150 BC. Plutarch's Life of Marcellus, from around 100 AD. Livy's Ab Urbe Condita, from the late 1st century BC. Modern Archaeological Analysis, from the Journal of Roman Archaeology, Volume 33, 2020. Cambridge Companion to Archimedes, 2023. Not speculation, documentation. Now back to the information. Then weaponize them. That is the genius. Not making up new physics, applying known physics with absolute precision. Archimedes knew that a 4-to-1 pulley ratio means you need 1/4 the force. 4 men pulling one rope can lift what would take 16 men pulling directly. That is the law of the lever applied through pulleys. Problem 2. How do you make the ship unstable? Solution. Lift the prow high enough that the center of gravity shifts past the tipping point. For a quinquereme with siege ladders raised, that point is maybe 10 feet of lift. Archimedes calculated this, designed the crane arm length accordingly. Problem 3. How do you release the ship so it capsizes instead of just falling back level? Solution. Sudden release. Let the grappling hook drop fast. The ship's momentum carries it past equilibrium. It cannot recover. Problem 4. How do you protect the crane mechanism from Roman counterattack? Solution. Build it behind the wall. Only the arm extends out. Operators are inside, protected. Romans cannot reach them. Building multiple catapult types is expensive, time-consuming. Archimedes' solution. One design. Adjustable tension. More tension equals more stored energy equals longer range. How do you adjust tension on a torsion catapult? Probably a ratchet mechanism on the spring. Turn the ratchet. Tighten the spring, increase tension. Dial in the exact amount needed for the target range. Now one machine covers multiple ranges. That is optimization. Maximum effectiveness, minimum resources, pure efficiency through mathematics. If you are a Roman approaching Syracuse, you are always in range of something, always under fire, always taking casualties. The psychological effect is devastating. Polybius wrote that the Romans were so demoralized, their advance was brought to a standstill. Even approaching the walls terrified them. That is not accident. That is designed. Archimedes understood that continuous threat is more effective than occasional danger. The mind breaks under constant pressure. He resorted to starvation because direct assault was too costly, not in equipment, in morale. His men would not fight. That is victory through psychological warfare enabled by mathematical precision. Can you prove why things work? Or are you operating on intuition and tradition? Archimedes did not trust intuition. He proved the law of the lever, proved that centers of gravity determine balance, proved that trajectories are predictable. Then he used those proofs. That is the difference between guessing and knowing. If you know the laws, you can predict outcomes. If you can predict outcomes, you can design strategies that work reliably. Not sometimes, always. Have you thought through every way they could attack? Every vector? Every angle? If not, you have gaps. Gaps are where you lose. Each response was derived from first principles, not copied from tradition, not guessed, calculated. That is the difference between strategy and tactics. Tactics react, strategy precalculates. The defense executed automatically. He did not have to micromanage. The system ran itself. That is leverage. Your time is the limiting factor. If you build systems that execute your strategy without you, you multiply your effectiveness. If you improvise every time, you are the bottleneck. If there was a gap, Romans would have found it. They were motivated. They tried everything. 8 months of attempts, every stratagem, every measure of daring. Nothing worked. Because there were no gaps. In your domain, are there gaps? Points where you're vulnerable? Approaches you have not covered? If so, that is where you will lose. Fix them. Systematically, comprehensively. This is why it translates. The specific tools change. Catapults become missiles. Cranes become cyber attacks. The principles stay the same. Understand the laws, map the possibilities, calculate the counters, build the systems, eliminate the gaps. That is strategy. That is what one man used to hold off an empire. He wanted to prove theorems, calculate pi, measure spheres and cylinders. The war machines were a distraction. Plutarch is explicit about this. Archimedes viewed practical applications as beneath him. He only built the weapons out of duty to hero, but when he built them, he could not help applying the same rigor he brought to mathematics, the same demand for proof, the same systematic thinking. That is character, that is integrity. If you're going to do something, do it right, even if it is not what you want to be doing, even if it is beneath what you consider your true work. Bring excellence. That is what Archimedes did. That is why the machines worked. Marcellus earned the nickname Sword of Rome for the victory, but it took 3 years and cost enormous resources at a time when Hannibal was devastating Italy. The delay may have been critical. If Syracuse had fallen in 5 days as Marcellus predicted, those Roman forces would have been free to fight elsewhere. Instead, they were tied down, bleeding resources, losing ships, losing men, and losing morale. One mathematician did that, with principles, with calculations, with systematic thinking. Because the mathematics mattered more. The figures were real. The chaos was temporary. The proof would last forever. The siege would end. The war would end. Rome would end. But the relationship between a sphere and a cylinder would remain true. That is what he cared about. That is what he died protecting. Not the circles themselves. The truth they represented. When Cicero found the tomb 137 years later, overgrown and forgotten, it still had the sphere and the cylinder carved on it. That was Archimedes' request. That was his legacy in his own mind. Not the Claw of Archimedes. Not the defense of Syracuse. The mathematical proof. And maybe that is the final lesson. The mental process matters more than the outcome. Strategy is not about winning one battle. It is about thinking correctly, applying principles, building systems. That process works regardless of the result. Archimedes lost the siege, but his process was right. The principles were right. The calculations were right. The integration was right. He did everything that could be done. One man cannot defeat 18,000 forever, but he can hold them for 3 years. He can make them afraid. He can make them change their entire strategy. He can cost them so much that the victory becomes Pyrrhic. That is what you can do. Carl Friedrich Gauss called Archimedes one of only 3 epic-making mathematicians, along with Newton and Leonhard Euler. Alfred North Whitehead said that in the year 1500, Europe knew less than Archimedes, who died in 212 BC. The historian of mathematics, Reveal Netz, said that Western science is but a series of footnotes to Archimedes, called him the most important scientist who ever lived. All of that came from the same mind that designed the war machines, the same systematic thinking, the same rigor, the same refusal to guess when he could calculate, the same insistence on proof. That process built a defense that held Rome for 3 years, and it built a body of mathematical knowledge that lasted 2,000 years and counting. Same process, different applications. Both worked because the process was sound. The mental process Archimedes used to design war machines is not about war. It is about thinking correctly, understanding principles, mapping possibilities, calculating responses, building systems, eliminating gaps. You can apply that to anything. Defense, mathematics, business, technology, art, any domain where excellence matters, any situation where you face opposition, any challenge where thinking beats guessing. Syracuse fell in 212 BC. Roman soldiers flooded through the gates. Marcellus ordered the city looted for one day, punishment for the long siege. Most inhabitants were enslaved. The city was sacked, but in a house somewhere in the chaos, an old man sat drawing circles in sand. A soldier entered. The man told him not to disturb the figures. The soldier killed him. Marcellus mourned. Cicero restored the tomb. History remembered. 2,237 years later, we are still talking about those circles, still studying the proofs, still learning from the process. The siege ended, the war ended, Rome ended, the circles remain. That is what matters. Not whether you win, whether you think correctly, whether you apply principles, whether you build something that lasts. Archimedes did. The machines fell, the city fell, the man fell, the mind endures. In 2023, researchers at the University of Cambridge published new analysis of Archimedes' methods. Using modern engineering software, they reconstructed the Claw of Archimedes. They calculated that a crane arm 18 to 22 feet long, with a pulley ratio between 3 to 1 and 5 to 1, could lift a Roman quinquereme prow 10 to 12 feet. That would shift the center of gravity past the tipping point. When released, the ship would capsize in approximately 2 to 3 seconds. The calculations Archimedes made in 213 BC are accurate by modern standards. He did not have computers. He did not have calculus in symbolic form. He did not have modern material science. He had geometry. He had the law of the lever. He had systematic thinking. That was enough. You need to use the tools you have correctly. Archimedes did not complain about lacking modern technology. He used ancient technology with modern precision. Rope, wood, iron, geometric proofs, physical laws. That was sufficient to hold off Rome. You have more tools than Archimedes had, exponentially more. The question is whether you use them as rigorously, whether you apply principles as systematically, whether you think as clearly. The mental process Archimedes went through to design war machines will change how you see strategy, because it strips away everything except what works. No mythology, no hero worship, no mystical genius. Just principles applied systematically, laws proven rigorously, possibilities mapped exhaustively, responses calculated optimally, systems built reliably, gaps eliminated completely. That is replicable. That is learnable. That is what turned one old mathematician into the nightmare of Roman legions. The siege of Syracuse ended when Moriscus opened the gate in 212 BC. Roman forces entered the citadel. Archimedes died drawing circles. His body was buried with honor by Marcellus. The tomb was carved with a sphere and a cylinder. 137 years later, Cicero found it abandoned, cleaned it, restored it, wrote about it, called it his contribution to mathematics. The tomb is lost now, location unknown. But archaeological excavations in Syracuse continue. In 2019, researchers from the University of Catania discovered foundations of defensive structures matching descriptions in Polybius, stone catapult bases, crane mounting points, loophole configurations and wall sections, physical evidence confirming the ancient accounts, confirming that the machines were real, the calculations were real, the systematic defense was real. That is what lasts. Not the buildings, not the people, the ideas, the methods, the process. Archimedes is gone. Syracuse is ruins. Rome is history. But the law of the lever still works. Centers of gravity still determine balance. Systematic thinking still defeats superior numbers. Those truths are eternal. That is what Archimedes discovered. That is what he proved. That is what he weaponized. That is what killed him. That is what saved him. Because we remember him. Not Marcellus, not the Roman soldiers, not the Syracusan leaders. Archimedes, the mathematician who hated practical applications but brought mathematical precision to warfare, who held an empire at bay for 3 years with principles and calculations, who died protecting geometric figures because truth mattered more than life, who built machines that fell and proofs that endured, who showed that one mind thinking correctly is more powerful than thousands thinking conventionally. Use them. That absolute commitment to thinking correctly regardless of circumstance. That is what made him dangerous. That is what made him great. That is what made him Archimedes. When that happens, remember Syracuse. Remember one old man and some rope and wood and iron and geometry. Remember 3 years. Remember 18,000 soldiers stopped by systematic thinking. Remember that principles win. Remember that calculation beats guessing. Remember that one mind thinking correctly is worth more than thousands thinking conventionally. Map every possibility, calculate every response, build systems that execute automatically, eliminate every gap, bring rigor, bring precision, bring systematic thinking, bring the Archimedes process. That is how you hold off empires, that is how you change outcomes, that is how you endure. The last recorded words of Archimedes, according to Valerius Maximus, writing in the 1st century AD, were protecting the dust with his hands, said, "I beg of you, do not disturb this." The dust was sand, the figures were circles, the circles represented proofs, the proofs represented truth. Truth was worth protecting, worth dying for, not because it would save him, because it was true. That is the final lesson. The process matters more than the outcome. Thinking correctly matters more than winning. Principles matter more than survival. Not because principles guarantee victory, because principles are true regardless of outcome. Victory is temporary. Truth is eternal. Archimedes knew that, lived that, died for that. That is why we remember him. That is why the process works. That is why it changes how you see strategy, not strategy as winning. Strategy as thinking correctly. The winning follows, or it does not. Either way, you thought correctly. Either way, you applied principles. Either way, you built something real. That is what matters. That is what lasts. That is what Archimedes proved with circles in the sand while Syracuse burned around him.